Hi there. Today we are going to see machine learning CPU versus GPU. And in this video, I'll show you what is the difference in terms of architecture, in terms of algorithm, as well as in terms of performance. So the business case which I have for you today is we have a bank which would like to use machine learning to train a model which can predict a loan payback. And the data which is being used is something like this. So you have all the data for the past loan applications, and this data has got the annual income, it has got the debt to income ratio, the credit score, loan amount, interest rate, as well as it has got information regarding the loan applicant. In addition, it also has got this column loan paid back, which is 1 and 0. 1 means the loan was paid back in the past, and 0 means it was not paid back. So you can use this data to train a machine learning model. Let us first see on how you can do that on a CPU. So first of all, you need to identify what are the x and y variables. So y variable here is the target variable. It means the variable which we want to predict, which is the loan paid back. And all other columns which you saw in the previous table are the x. Then you need to identify what are the numerical columns and what are the categorical columns. And then you have to apply some transformations. So for all the numerical columns, you have to scale them. It means you have to convert them into values between 0 and 1. And for all the non-numerical columns, or also called as the categorical columns, you have to transform them using one-hot encoding. And I'll explain you later on what is this one-hot encoding. And then you can use various machine learning models. And one of the very famous machine learning models which you can use on a CPU is a random forest classifier. So you can train the model. It would look something like this. You apply the standard scaler as well as one-hot encoder, and then you apply your model. Now, once you do that, you'll get a model accuracy of 90%, as well as the model training time is quite high. It is almost about 681 seconds, which is roughly 10 minutes, which is quite high. Now, let us see on how you can do the same task, but this time using a GPU. So here the GPU which I'm using is the Apple GPU, also called as Metal. So the initial steps are similar. You have to identify the X and Y and apply this pre-processing. But the difference is in the model training. So here I'm using a model training library which is called as PyTorch. And this is based on a deep learning architecture. And the reason why I'm using this is because you can train a machine learning model on a GPU using a deep learning architecture. So here, deep learning architecture, you have to create various layers, and for this reason, this is called as deep learning. And you'll see a model something like this. You'll have these different layers of the neural network, which is shown over here. And you'll get a model accuracy of 90%, but this time the processing is quite fast. The complete training gets completed in just 32 seconds, which is 200 times faster than the CPU. So why is there a big difference between the CPU and GPU? And one of the main reasons is the volume of data. So the data what we are using for the loan applications has almost about 500,000 rows, which is like 500,000 rows. And also the logic of one-hot encoding increases the number of columns. So for example, let's say you have a column called as education level, and which has got these three values. And when you apply this one-hot encoding, it gets converted into multiple columns, all with 1 or 0. So in total, we have 16 columns. And when you apply this one-hot encoding, the training data consists of 70 columns. So you have a data set which has got 500,000 of lines as well as 70 columns, which is quite huge. And a GPU would always excel compared to a CPU when the data is very, very high. The other factor is that the deep learning algorithm can also be effectively parallelized on a GPU, which is not possible using the random forest classifier. So it's for these two reasons, the parallelization of algorithm as well as the volume of data gives the GPU an edge over the CPU. Now, let us do a quick knowledge check to see if you understood this concept. So first of all, what is the common algorithm to train a machine learning model on a CPU? And I'll give you 1 second to think about it. All right, so the answer is random forest. Second question, what is a common algorithm to train a machine learning model but on a GPU? And once again, I'm going to give you 1 second to think about it. All right, so the answer is deep learning. Third question, why is a GPU faster than a CPU? All right, because you can parallelize the algorithm using a GPU. Thank you for watching.